which is the quadratic formula and the discriminant. Most of this should be reviewed because you've already learned the quadratic formula in Algebra 1. So recall the quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. Remember that a, b, and c are the values from the equation when it's in standard form. So be sure always, if you're going to use the quadratic formula, that the equation is in standard form. Okay? Equation must be in standard form. So if you need to rearrange it, then rearrange it. Okay, so let's take a look at these together. We'll at least start each one of them, and I may ask you to finish them. So the first one is very nice because it's already in standard form. So my a value is 1, my b value is -3, and my c value is -28. So we'll plug that right into the formula. Negative b will be -3, which is +3, plus or minus the square root of b squared minus 4ac. All over, and remember the entire thing is over 2a. So now we'll go ahead and we'll simplify the inside part. So this will be 3 plus or minus the square root of 9, and 4 times 28 gives me 112. So this will become plus 112 all over 2. I like the looks of this because 3 plus or minus the 9 plus 112 gives me 121, which is a perfect square. So this will become a nice set of solutions. We'll continue to simplify, and we'll get that 3 plus or minus the square root of 121 is 11. At this point, we can now break it into two different solutions. One of our solutions is 3 plus 11 over 2, and the other is 3 minus 11 over 2. When we do that, 3 plus 11 is 14, 14 over 2 is 7, and 3 minus 11 is -8, and -8 over 2 is -4. Now remember, our variable is t here, so that's saying that t equals 7 and -4, or as a solution set, -4 and 7. Okay, let's look at number 2 together. So number 2, the first thing that we need to remember to do is to put this into standard form. So we'll subtract the 5p, and we'll have 3p squared minus 5p plus 9 equals 0. Again, we can identify that a is 3, b is -5, and c is 9. So that's telling us that for our quadratic formula, negative b will be +5 plus or minus b squared minus 4ac. Negative b plus or minus b squared minus 4ac all over 2a. And we will continue to simplify. 5 is out front, and we get 25. And 12 times 9 is 108. So we'll have minus 108 all over 6. Continue. This gives us 5 plus or minus 25 minus 108 is the square root of -83 all over 6. Now, normally we would say, well, we can't have a negative, and that would be no real solution. However, recall, now we've learned about imaginary numbers. So I look to break up the square root of -83. There are not any perfect squares that go into 83. However, because of the negative inside, we can pull out an I. So I now have 5 plus or minus I root 83 all over 6. There is no more simplifying we can do, so that means P equals 5 plus or minus I root 83 all over 6. Remember that is really two solutions. 5 plus I root 83 over 6 and 5 minus I root 83 over 6. And we leave it as is. Okay, let's keep on going. On number 3, what I would do on number 3 is I would clear those fractions. So I'm going to multiply by 4. That will give me x squared plus 18 equals 12x. Now be sure to put it into standard form. So x squared minus 12x plus 18 equals 0. From here, we will now use our quadratic formula. So negative b is positive 12 plus or minus b squared minus 4ac all over 2a. Continue with that. 12 plus or minus the square root of 144 minus 4 times 18 is 72 all over 2. At that point, we can simplify, which gives me 12 plus or minus the square root of 72 all over 2. From here, we look to see if I can simplify. Well, 72 isn't a perfect square, but I do know that 72 is the same thing as 36 times 2. So remember that. 72 is the same thing as 36 times 2. Whoopsies. Apologize. 36 times 2. So when I take that square root, what we'll have when we simplify, bring it up over here, is we'll have 12 plus or minus, the square root of 36 is 6, so that can come out, and root 2 stays in, all over 2. Now we keep on simplifying. Everything on the outside of the radical is divisible by 2, so we can simplify. But again, everything on the outside must be divisible by the denominator. We will not reduce the radical though. So if I divide the 12 and 6 by 2, that will give me 6 plus or minus 3 root 2, and no denominator left. And there are my solutions. 6 plus 3 root 2 and 6 minus 3 root 2. If we were asked to approximate, then in your calculator you would do 6 plus 3 root 2, get your answer, and then in your calculator, 6 minus 3 root 2. Okay, let's look at one more example together, and hopefully you'll have a good, strong understanding of how we use the quadratic formula. So again, priority 1, let's get this in standard form. This is going to become, subtract our v squared, so that'll give us 5v squared, and then minus 2 equals 0. So we subtract our v squared and we subtract our 7. So at this point, what we need to remember is that our a is 5, our b value is 0, and c is negative 2. And that's okay. Okay, we'll just continue to use the quadratic formula, which says that it equals b squared minus the square root of, jumping ahead. It equals negative b plus or minus the square root of b squared minus 4ac. Okay, so negative b plus or minus b squared minus 4ac all over 2a. So when we simplify that, of course, we have 0 out front, and this will give us 0 plus 40 all over 10. We'll keep on simplifying. This will become 0 plus or minus the square root of 40. Now remember, the square root of 40 is really 4 times 10. So that is 2 root 10. but we still have the plus or minus out front, all over 10. Okay, so the square root of 40 is 4 times 10, which is 2 root 10. I still have the plus or minus out front, and now I can divide the 2 and the 10, which means that v will equal plus or minus root 10 over 5. So again, we have two solutions. And there you have it. Okay. Hopefully you feel confident with how to use the quadratic formula and the different answers that could come up. We could have nice integers or fractions even that come out. We could have imaginary solutions, right? Complex numbers. We could also have irrational answers with the radicals that could be simplified. And recall, you could potentially just have one answer as well. All right, let's continue on to discriminant. So what is the discriminant? The discriminant is used so that you don't have to actually do the entire problem out, but you could figure out how many roots you'll have and the nature of them. What do I mean by the nature of them? I mean, are they going to come out nice and pretty as rational numbers, like in number 1? Or are they going to come out imaginary numbers, like in 2? Or maybe are they going to come out irrational, like in 3 and 4? So the discriminant is simply the part inside the radical of the quadratic formula, which is b squared minus 4ac. If that discriminant is positive, then we have 2 real roots. If the discriminant is 0, then there is 1 real rational root. So we'll get one answer, and it will be rational. If the discriminant is negative, then we have 2 imaginary roots. Now, let's go back to if it's positive. If it's positive, we get 2 real roots, but they could either be rational or irrational. If we can take a perfect square, so that discriminant is a perfect square, it'll come out as rational roots. But if it's not a perfect square, it'll be irrational. Okay, so that's like 1 and 3. Number 1, we have that positive discriminant, right? Inside the radical was 121, and that's a perfect square. So we got 2 rational roots. However, on number 3, we got a positive, but that discriminant was 72, which is not a perfect square. So that's why we got real roots, no imaginaries, but they were irrational. So let's look at some examples now that involve the discriminant. So the first one is saying determine the nature of the roots given the equation. Well, if we're going to use the discriminant, it's important that we are in standard form so we can properly identify our A, B, and C values. Now that discriminant is simply that part under the radical again, which is b squared, so negative 12 squared, minus 4ac. We'll simplify that. So that's going to be 144. This will become a plus. And remember, now 4 times 11 times 10 gives me 440. When I add those together, I get 584. So what we need to think about is that number positive? Is it 0 or negative? So since it is positive, I know we're going to have 2 real roots. Now the question is, are they going to be rational or irrational? So is 584 a perfect square? 584 is not a perfect square. So what that means is that we'll have 2 real irrational roots. If it was 0, we'd have 1 real rational root. And again, if it was negative, no matter what the number is, as long as it's negative, we have 2 imaginary roots. Okay, the last example. What must k equal to have 2 real roots? So if I want to have 2 real roots, remember that means the discriminant must be positive. Or 0. Right? If I go back up to my chart to have real roots, I'm either positive or 0. So what's another way to describe that? That means that discriminant must be greater than or equal to 0, right? To be positive or 0, it must be greater than or equal to. Our discriminant is b squared minus 4ac. So I'll pop those values in. My a value is 1, the b value is 3, and my c value is k. So b squared minus 4ac has to be greater than or equal to 0. Let's keep solving. 9 minus 4k has to be greater than or equal to 0. Subtract 9, and now divide through by negative 4. What do we need to remember when we're dividing through by a negative? We need to flip that symbol. So k has to be less than or equal to 9/4. And there's your answer. Okay? When you're doing your practice problems, remember to pay attention to the question. If it's just saying how many roots, you don't need to do out the entire problem to solve the roots. If it's asking what are the roots, then yes, you need to do the entire quadratic formula out to figure out your solutions. Have a great rest of your day.